Okay, today you learn the fundamental theorem of calculus part 1. First, let's talk about part 2, because that's what we've already learned. And we learned this. Man, wow, I just fall for that every time. Integral a to b of f of x dx is equal to. Everybody remember what we did? Big F of b minus big F of a, where big F is any antiderivative of little f. AB so I've got this function f on the interval AB. Everybody good? Then g of x, we're going to say g of x is the area function. So area function means integral from some constant a to some variable x of f of t dt. Don't worry about the variable change. People freak out about it. You don't need to worry about it. So what happens here, what's being described by this guy right here, is that g of x is the area function. So if I pick a value x right here, can somebody tell me what happens as I move x that way? What happens to the area as I move x that way? The area gets bigger, right? What happens as I move x to the left? It gets smaller. So g of x is a function. As you move x, that thing changes. And it turns out that g of x is also continuous. And differentiable. And the biggest thing of all, and this is what we pointed out to you day one, the derivative of the area function. If you take the derivative of g prime of x, you get, in fact, f of x. The derivative of the area function is the function that bounds it. The derivative of the area function is the function that bounds it. That piece we're going to talk a lot about tomorrow. It's super cool. It'll make a lot of sense tomorrow. Right now, we're just kind of dangling it out there. Right now, we're going to focus on this guy. So let's look at this function. This is all we're going to get through today. We're going to hand you what we're doing, and tomorrow's lesson is very, very short. So if you don't have your homework done by Monday, it is the fault of one person, and that is not me. So you figure out how to get your stuff done when you got that time. Let g of x be the integral from -6 to x of f of t dt. It says evaluate g of -6. So that means the area of this function f from -6 to -6. So if I look at 1, 2, 3, 4, 5, 6, okay, right here, this is -6. Looks like my smartboard's just a little bit off today. Let's try again. Anybody want to guess what the area is from -6 to -6? 0. There is none, is there? You don't have any width. And if you don't have any width, you can't have any area. Now it wants to know g of -4. So that means instead of x, I plug in a -4. So I'm looking at area from -6 to -4. It is 2. Very good. I told you all we're doing during this unit is really just adding up the area of rectangles. Now I need to do g of -2. Oh boy. Well, it looks like I collect some more positive area, right? But then it looks like I get a little bit of some negative area, don't I? Would you agree that that positive area right there and that negative one cancel each other out? Yeah, if area is below the curve, it's called negative. I'm sorry, if it's below the x-axis, we call it negative. If it's above, we say it's positive. So therefore, what would the area there be? 3. Good. So now I'm going to collect the area up to 0. So I get another -1, a -2, a -3, a -4. Would you say that those two together make -5? -5. So if I collect -5, then what is g of 0? It's -2. Now I'm going to go up to g of 2. Am I collecting positive area or negative area? Negative area. So I'm collecting how much more negative area? -6. That's going to bring me to -8. Now I have g of 4. Looks like I've got another -1. Say a -2. Or maybe 2. So would you say that that little blue cancels with that little red? Okay, so what should we say that was when we say -2? So that'll bring me to -10. And then after that, g of 6, do I collect positive area or negative area? Sweet. So I've got all the way to 6. I've got 1, got 2, 3, 4, 5. I'm going to say about 6. Do you agree? Okay, so I've got about 6 there. Yeah. Oh, I'm sorry. Thank you. Thank you. Good catch. -4. Good catch. Thank you. Yep, you guys are smart. So what happens when I take it out? Okay. You're going to have an opportunity now to catch on to something that's going to make you smarter. Without a doubt, my guess is that I throw this out, probably only about 50% to 3/4 of people are going to catch it. We're going to give you a chance. It says, on what intervals is g of x increasing? That means where is the area becoming bigger? When is the area becoming bigger? From where to where? -6 to -2.5. And then 3.5 to infinity we'll go to, sure. Union 3.5 to infinity. Now, the fact is I expect 100% of people to make that connection, but I'm going to show you the connection that people really struggle to make. We'll see if you can see it. Okay? Increasing. When did we learn that a function is increasing? When f prime is what? Greater than 0, right? So think about it, folks. The question, function increasing. That's where its derivative is positive, right? What's the derivative of the area function? The derivative of the area function is the function that bounds it, right? Where is the function that bounds it positive? Wherever it's above the x-axis. So you can look at it two ways. You could say, hey, I'm going to look at where I'm gathering positive area, and that's going to be where it's increasing. Or you could say, well, the derivative of g prime is simply this function. Wherever it's above the x-axis, that's where it's positive or increasing, and then wherever it's below, that's where it would be decreasing. What intervals is g of x decreasing? Well, wherever f prime is less than 0. What's the derivative of g of x? The function that bounds it. When is this function less than 0? A 2.5 to 3.5. Where does g of x have a minimum? Hey, do you remember when we talked about things having local mins and local maxes? When did the local min occur? When f prime was changing from negative to positive. Well, what represents the derivative on this graph? F. When does it change from negative to positive? At 3.5. At 3.5, f, which is the derivative of g, that's where it changes from negative to positive. And finally, the last piece, if we want to sketch a rough graph of g of x, could we? Sure. It's not too tough. I'll draw g in green, and it's not an exact graph, it's just an estimation. It says g of negative 6 is 0. G of negative 4 is 2. So at negative 4, I'm going to go up to 2. G of negative 2 is 3. G of 0 is negative 10. I'm sorry, G of 2 is negative 8. G of 4 is negative 10. And G of 6 is negative 4. So if you kind of connected these dots, you would see the shape of G. Something like that. It's a rough graph. It's not exact. Before I hand to your stuff and let you have the rest of the hour, I just want to be clear. Would everybody agree that this would kind of be a local max because you're going from positive to negative? Well, look at the graph of G. It has a local max there, doesn't it? And you told me there's a local min at what value? 3.5. See, it goes down until it gets to there, and then it heads up because that's where it's going to be most negative. Tomorrow's lesson is even easier than today's lesson.